All right, in this video we are going to talk about Java file input and output. All right, so Java has at least two packages for file input and output. So the one that we will talk about is java.io, which is the older package for file input output. The newer package is called java.neo, and it's newer and it works differently than IO does. All right, so we're going to spend most of our time with java.io. So if you go to the Java API, and look up java.io, then you will see, all of the classes that are in that package, and there's quite a few. Okay, so that's what we're gonna. That's what we're gonna start talking about. All right. So the java.io package, it uses streams, what are called streams, or what it is referred to as streams. Input streams to read data from files, and output streams to write data to files. Okay. So the basic procedure is you would create the stream as an object, a stream object, right? And then use the stream to read or write from the file or other resource. Streams are unidirectional, right? So you have to get input with the input stream, and you have to write output with an output stream, right? It doesn't go both ways. That is one of the differences between IO and Neo, is that Neo uses something else called channels, which are bidirectional. You can kind of turn them one direction or the other direction. Okay? But for us, Java.io streams are unidirectional. And so once you are done reading or writing, then you need to close the stream. Okay? So that's the basic procedure. Create the stream, use it to read or write, and then close it. All right, so the first kind of files that we are going to deal with are called binary files. A binary file is a computer file that is not a text file. And so you can think of a binary file as a sequence of bytes, right? So just a bunch of zeros and ones, essentially, that are stored uh, on the disk. So some examples of binary files are compiled computer programs, right? If you try to open up one of those .class files, in JGrasp you'll see you'll get some weird output images, sound files, zip files, and a whole lot more. Okay. So just as an example, let's take a look here. I have that image that I showed you over here. I have it here on disk. If I open up in JGrasp, you'll see that I'll get this error. It says error decoding this file using charset Windows 1252. So that's just telling you, hey, this is not a text file, which I normally open. Okay. So it says you need to choose a different charset, which you can try to do, but it's a binary file, right? It's not a text file. So none of these are going to work. It says, or you can use binary mode. So this is a binary file, so we'll just say open in 8-bit binary mode and click continue. You can see that's what you're going to see when you open this up. Just basically a bunch of gibberish looking things in here. So this, stuff you can interpret as, most of it at least, you can interpret as bits of information. Like, for instance, 000B, right? 00C. Those are in hexadecimal format. Hexadecimal is base 16, and it allows you to write binary numbers in a much shorter fashion, right? So it uses the digits 0 through 9 and then the letters A, B, C, D, E, and F. And so this is short for probably 4 zeros, 4 zeros, 4 zeros, and then B would correspond to an 11, right? If you have 9, A would be 10, B would be 11, right? And if you write 11, the decimal number 11 in binary, right, it's going to be, let's see, what is it going to be? It's going to be 0 or 1, 0, 1, 1, right? Which would be 1 plus 2 plus 8, right? So that's what we've got here. This is a binary file, and you can kind of look at it in JGrasp. It will show you some of the bytes in there, and it interprets some of those things as some of those bytes in there as character sets. And so you can see we have some letters here. All right, so that's a binary file. You try to open it up like a text file, it's not going to make a whole lot of sense, right? Because there's no character encoding, and that's this image file right here. All right, so that's a binary file. So the first type of streams that we'll talk about are streams that provide a means for handling input and output to binary files, okay? And those are called byte streams. So the byte streams that we'll talk about are all child classes or descendants of two abstract classes called input stream and output stream, right? Input stream is an abstract class, and it is the parent class of a lot of the input byte stream classes in the java.io package. Remember, byte stream, right, is used for binary files. And output stream is an abstract class that is a parent class of a lot of the byte stream classes, output byte stream classes in the java.io package. Okay? All right. So let's take a look at that. All right, so here's our class input stream. You can see it has some child classes here. You can see it has an abstract method called read and an abstract, oh, that's the other one. So that's the main one that needs to get implemented. And so you can see the child classes are, again, as we talked about with inheritance, these are more specialized versions of input stream. Audio input stream is probably for audio files, right? And there's other types here as well that we'll talk about, okay? So these are some of the child classes of this input stream class. All right, so it kind of looks like this. Input stream has these child classes. A lot of these we aren't not going to talk about, but we will talk about file input stream. Later on, object input stream, and then buffered input stream and data input stream. We'll talk about those 4 different ones. It's fairly similar for the output stream class, right? This output stream class has the abstract write method, and some of the child classes that we'll be interested in are file output stream, object output stream, buffered output stream, and data output stream. Okay, so first off, we will talk about file input stream. File input stream and file output stream, they provide very basic byte streams for reading from and writing to binary files. So about as basic as you can get. In file input stream, you would use the read method to read data, and file output stream, you would use the write method. Okay. All right, so let's take a look at this example here. So our first example will be to write a program that uses the file input stream class and the file output stream class to make a copy of this image file right here. So we're going to read it, and then we are going to write it out. Okay. All right. So let's do that. So create a new class. I'm going to call it input output stream example. Okay, so we have our class header and the main method header in there. Okay, so what we are going to do is to create a file input stream object. And we are going to load up that JPEG that I showed you there. All right, when we go to do that, all right, the first error we get, right, is cannot find symbol. So we do not have the import for that. So it's java.io.asterisk, right? That will work. Okay, so you can see it's a different error. All right. I am going to, so you can do that, and it's going to be a lot easier than what I'm going to show you. I am just going to list these one by one, just so you can see what the minimal classes that we are using are. Okay, so file input stream. Okay, so now it recognizes the class file input stream. The thing we're getting this error on, right, is that this is a checked exception, right? File input stream, the constructor throws a file not found exception, right? And so this is a checked exception. The reason being, right, this file might not exist, and Java wants to know, hey, what's the plan? What are we going to do if this file doesn't exist? Okay. All right. So this needs to be in a try block. And of course we need to catch the file not found exception that it's going to throw. Okay. And we're just going to print a message saying file not found. For now. All right, so let's see how that goes. All right, so next up, right, we get that it can't find the symbol file not found exception. That would have been fine had I put import java.io.asterisk, right? But again, I just want to show you the exact classes that we're having to use here. All right, so let's run that. All right, so all that's really happening right now is that we are opening up this file. And just to show you what happens if I change the name to the name of a file that's not in this directory, you can see there's the message that we get that we cannot find that file. Okay. Okay, so next up, right, what I want to do is to read from the file, okay? So what I would do then is when I read, you're going to read it in as an int, okay? So I'm going to read an int in, right? And it's really a byte is what it's going to be. So if I look in the file input stream class at the implementation of the read method, right? It says this reads a byte of data from this input stream, okay? And it returns an int. All right, and if we look at the detail on it, it says reads a byte of data, right? This method blocks if no input is yet available, right? So it means it will hold up your program. And it returns the next byte of data, or a -1 if the end of the file is reached, okay? So what we're going to do when we run this is read the next byte, and that would just be in.read, okay? So that is your file input stream object, and I'm using the read method, okay? I'm just going to print it out so you can see what we get. Okay. Before we can do that, right, then we get this unreported exception, IO exception, must be caught or declared to be thrown, okay? So we need to add another catch block down here. Oops. IO exception. And I'm just going to print something similar to what I printed here. All right, getting that cannot find symbol again, so gonna have to add another import. All right, and so we should be good now. All right, so here we get 255, okay? So that is the encoding, right, of that decimal version, I guess, of that byte, right? Which should go from 0 to 255. All right, so that's what we get. We basically read the first byte of data from that image, okay? All right, so what we want to do then is not just read just the first byte. What we want to do is read the entire file, right? And so what we'll do then is to create a while loop, all right? So, and the variable that we're going to use to control this loop is this next byte right here. So next byte, and while it's not equal to -1. Okay. So, so this loop, right, will keep reading. Actually, it won't. We have to add something else in here. But the goal of this, right, is to keep reading from this loop right here, or keep this loop going and keep reading. We need to also down here change, right, the value of next byte. So we need to read the next one. So it's going to read that first byte, and then if it's not -1, right, then it's going to print that out and read the next one. And eventually we'll get rid of this print here in just a second. So it's going to read the next byte. You know, if that is -1, then the loop is going to quit reading, right, because it'll be -1 when it hits the end of the file, right? If it's anything other than -1, then it will read the next one, and so on and so forth. So that will go all the way through, and hopefully this doesn't go too crazy. All right, yeah, that's not too bad. All right, so you can see it read all of the bytes out and printed them out as integers in there. Okay. All right, so that's what's going on right there. All right, so if you think back to what we've done here, in terms of the overall scheme that I mentioned before, right, for reading and writing, create the stream, we've done that. Use the stream to read or write from the file or other resource, we've done that. So the last thing here, at least for the input stream, and we're going to have to do this all for the output stream as well, but the next thing would be to close the stream, okay? All right, so to close the input file, right, what you would do is to close it, right? And so to do that, you're going to use the close method, which if we look through, you can find it here. All right, so this thing will close the input file, and in this case what we'll need to do, right, is, and we haven't done this before, but if you remember back to the flow of execution with the try and catch block, right, the try, if everything goes smoothly, right, in the try block, then the catch blocks will never get executed. All right, something might go wrong in and then the flow of execution will transfer to these catch blocks, right? And the block that we haven't used is the finally block yet, okay? So in the finally block, right, remember, just a refresher on what that is, the finally block, the code in there will get executed regardless of whether or not the try block threw an exception or not. So if everything was fine, or even if something went wrong, the code that you put in here will get executed either way, okay? So that's important. So what we want to do is to close our file object up here, okay? So we want to close this out. But when I go to compile it, you're going to see there's an issue, okay? So go to compile, and it says error, right, cannot find symbol, okay? So the issue there, right, is we are trying to use the object in, and that was declared here, right? And so if you go backwards to the first open curly brace, it's this block right here. So that variable can be used within that block, okay? And we are trying to use it in a different block down here, right? That's a problem. That one's easy to fix, right? If you studied the stuff, the material from the exceptions chapter, right? Because that's a super common thing. And all we do is move the declaration, right, of the object a little bit higher. So outside of the if we try to create it out here, we're going to get that error again that says that's an unchecked exception. It has to go in a try and catch block, right? So really, we don't have a whole lot of choice but to declare this as null up here, okay? Because, like I said, that's the whole reason why we put this file input stream inside the try block anyway, because this constructor throws a checked exception, right? So back this off. All right, and now compile that, okay? All right, and so you can see we no longer get that error, but now we have a different error, all right? All right, and so the thing is that this close, right, this close object throws an exception, an IO exception, and so it is a checked exception. All right, and so that is a problem. All right, so what we're going to have to do is go and put a try and catch block down here. All right, on the close. So try to close this out. And the close method, right, throws an IO exception. And I'm not going to do anything different than what I'm doing here. Now, as you're probably starting to notice, this is getting kind of complicated. So just bear with me, okay? Because in the next video, or not next video, but in the next example after this, I'm going to show you a better way to do this, okay? So just stay with me here, okay? All right, so that looks okay. So now the thing is let's see if I can trigger this to happen. Everything now is running fine. So if I, let's say, have a file not found error right here, and I try to run it, you're going to see that it crashes, okay? Which is not good if you're trying to write a program where your program doesn't crash, right? And you have to, reading from files and writing to files is a really common thing in, commercial software. So that's a problem. You wouldn't want this thing to crash. And so this is a, fairly tricky part of this, is that the reason why this crashed was that I created file input stream as null, right? I had to do that, and I didn't really have any choice. I had to move it up here because otherwise I would have had to put this in another try and catch block, and I would have had the same issue. So I had to move it up here. I had to set it to null, right? And then it didn't find this file, right? Because I tried to trigger this on purpose, right? So what that means is that when it bumped down here to this finally block, right, in was a null object, right? It had never been created. And so that's a problem. And that triggered this null pointer exception, right? So to get around that issue, right, what you would do is right here, add an if statement. If in is not equal to null, okay? And then move all this over. Like so. All right, so what will happen here is that if in is not equal to null, right, then I won't get that problem anymore. So now watch if I try to run this, right, again, here this file doesn't exist, so that's going to trigger an exception, right, and it's going to jump down here to this file not found exception. It's going to continue on its way, and it's going to check. And here it's going to discover that this is false, right? In has never been created. So basically we're saying, hey, don't try to close a file that hasn't been created. So you can see now we no longer have that null pointer exception, okay? All right, so I think that's it for the input stream. So we are good, all right? So this is reading, right, to this input stream, or reading from this file. Let me change it back to the regular name here. All right, and check everything's good. So we should get no messages here. All right, so that is the input part. All right, next up is the output part. All right, and basically we are going to do pretty much exactly the same thing as we did with the input stream. So we are going to create a null file output stream object up here. Okay. Then we are going to create inside the try block a new file output stream object. And I'm going to call this one 1234 copy underscore copy dot jpg. Okay, so that creates the new file output stream. Let's just double check that. All right, I cannot find stream, right? So I'm going to have to add that class in there as well. Well, java.io file output stream. Okay, so we've created our output stream, right? Then what the next thing to do, right, is to write to that. All right, so in this loop, right, whenever we read a byte, right, the thing that we're going to do is write that byte out. So read this byte, then we're going to write it to this output stream right here. So our file output stream is out, so we do out.write, and then we just write that byte out to it. Okay. All right, we can get rid of this. All right, so here is the second part, right? We are using the write method in our file output stream to write, and then what we have to do is close it down here in the end. So again, it's going to be very similar to this. I'm going to have just basically copy this entire block here and change this to out if out is not null, and it definitely could happen, right? That it be null. Then if it's not null, then close it. Okay. All right, let's compile that and see if it works. Looks good, right? And so now we are ready to run it. So when I run this, right, what should happen is that I should generate another file over here. I may have to refresh it, right, to get it to show up. All right, so run it. All right, so there it is right there. Came up. All right, so you can see there's the copy, and then now to verify that it actually is a copy, go over here, right, and you can see that's that directory. If I open this up, and there it is. All right, so you can see that's an exact copy of that image. All right, so that's the basic use of file input stream and file output stream to copy a binary file, right? These are byte streams meant to copy, read from, and output to binary binary files, right? So you're probably thinking, man, that is a lot of work just to copy files, and it is, right? We have a lot of stuff going on here, okay? And so, like I said, don't panic about it too much, because we're going to simplify it a little bit, okay? All right. So that's what we're going to talk about next. Okay, so the thing that simplifies what we just did is called try with resources, and I know that going through that example is, it's kind of long, but it's good to go through that example so you can see, the benefit of using try with resources. So the try with resources statement is a special kind of try statement. It was introduced in Java 7. Okay, and so a resource, right? Try with resource. A resource is an object that must be closed after the program is finished with it. So just like the file input stream and file output streams that we were talking about in the previous example. Okay, and so a try with resource statement, what it will do is take care of the closing part for you. So you don't have to do that at all. All right. So if you look back at our example here, a lot of our code was all this junk down here about closing that out, and so you won't have to do that. The try with resources will automatically take care of it for you. You can see if you want to know, say, which objects can I use as a resource, which objects can I not use as a resource, right? Any object that implements the auto closable interface can be used as a resource. So if we go look at file input stream, right, if we go up, scroll up here to the top and look, we can see that it implements the auto closable interface. So that means you can use it as a resource in the try with resources statement. Okay. All right. So so the basic form of the try with resources statement, it's a lot like the regular try statement. The big difference is up here as far as the way it looks. Okay. So you have try and then some an open parenthesis. Inside the parentheses, you will put your resources, okay, that you are creating. So, for instance, in the last program, we had a file input stream, right? That was one of the resources, and we had a file output stream, okay? So those go in parentheses, and you need to separate those object creations with a semicolon. And remember, what we were doing was this eliminates the need to put that file input stream, declare it before the try block, right, for the purpose of closing it in the finally block. We no longer have to close it. So that means less use of the finally block here. All right, our processing code will go in the try block, and then we'll have our catch blocks as normal. Okay. So that's a try with resources statement. So in this try with resources.java, all right, so this is the exact same program that we wrote before. It does exactly the same thing, the one that we just got done doing. All right, so here you can see, here's your try with resources statement. Inside there, you would create your file input stream, file output stream objects, right? This code was exactly the same, right? We would read the first byte, and then we'd have this little loop that would go through, right, and read and write bytes, right, as long as next byte is not equal to -1, right? And that means if it's -1, that means that it's at the end of the file. All right, so that part's exactly the same as we had before. We had still have to have these catch blocks, right? One for the checked exception here if it's not able to create this input stream or output stream, and then one for the IO exception. If something goes wrong while this thing's being read, then it will come here or execute this code in this catch block. Okay. But you can see that's it. So that is a lot shorter, right, than what we had before. So if we compare that, right, this code is all the same. All this is all the same. This finally block, right, you no longer have to do. You can see, boom, it's gone. Reason being, try with resources is going to take care of all that stuff for you. All right, so hopefully you feel a lot better about this version, right? This one is pretty straightforward. So again, make sure that you're using this try with resources. All right. Okay, almost done. The last two that we'll talk about in this video are the buffered input stream and buffered output streams. So a buffered stream reads data from and writes data to a memory area known as a buffer. So there's kind of an intermediary, right? That file input stream and file output stream were pretty much direct from one source to the other. And so what might happen is that, you know, there might just be some issues, and that's why the IO exception is a checked exception. Maybe, you know, something weird goes wrong with the reading and writing of the bytes in there. So what a buffered stream will do is write things to the memory. So say some of your hardware gets tied up and you can't write to the file, then that stuff just is hanging around in memory. Whereas if you are writing with a unbuffered stream, maybe you just lose those bytes. It just kind of depends. All right. Whereas with the buffered stream, it's going to store. It's basically like a line in the memory where those bytes are stored, and they can wait if they have to wait to be written to the disk or something like that. Okay. So buffered streams are generally more efficient than those that are not buffered. So the classes that we will talk about are buffered input stream and buffered output stream. Those provide buffered byte streams for reading from and writing to binary files. And so you're going to see it's a lot like a lot like what we did before with file input stream and file output stream. For that example we did, that image is not very big, right? That image that we copied. And so it's probably, you know, not very likely that you would have issues with a small file like that. But, you know, if you're copying large amounts of data, then, you know, binary files, then you probably would want to use the buffered input stream and buffered output stream. So let's take a look at that. So we're going to see it's really similar to what we've done here already. There's not much difference. Okay. So you can see, right, the difference up here. Well, the first difference is that I now have 4 resources that I create. All right, I create a file input stream just like I did before. But now what I do is that object that I create, that file input stream object that I create, I pass it to the constructor of a buffered input stream. So that's basically wrapping a buffered input stream around this file input stream that I created. Okay. Then I do the same thing for the file output stream. I create a file output stream just like I did before. Okay. Then I wrap that in a buffered output stream object, right, by passing it to the constructor. All right. And then everything else is exactly the same. Read, check the next byte, make sure it's not equal to -1, right? Checking to see if we're at the end of the file. If not, then write next byte and then read the next one. And then I have my 2 catch clauses that are required, right, for these things, for the creation of those constructors. All right, and you can see runs and it creates this next copy, right, of that image there. Okay, so this is a little bit more sophisticated, right, and it'll handle more intense jobs than the regular file output stream and file input stream will. And you can see there's not a whole lot of overhead either involved with setting these up. You just basically 2 more lines than you would have with regular file input stream and file output stream. Okay. All right. So I think that is it on this video. Yes. And we will talk next time about data input stream and object input stream and output stream.